Hello everyone, I am Varshini from Sri Venkateshwara College of Engineering, pursuing my data science engineering. Today we will be discussing about the subject operating systems, and our topic is understanding the architecture of operating systems. Now, the first topic is the introduction to operating system. What exactly does an operating system do? Operating system is a system software that manages computer hardware, software resources, and provides common services for computer programs. The OS acts as an intermediary between the user and the computer hardware. So, what exactly is the operating system? It is like a imaginary interface between the user and the computer system. When the user types in a command or what we want the computer to do, we should have something or somebody in the computer who will allocate certain resources. If I type something, it has to understand that when I type something, it has to be shown on the screen. Then the screen has to be informed that whatever is being typing should be shown on the screen. So for this intermediary task or this manager's work, we will use the operating system. Points of importance are facilitates user interaction with computer. It manages software efficiently, provides a stable, consistent way for application to deal with hardware. Even though our application has all the components or peripheral devices that we need in the computer, what is the point if we don't know how to utilize it, and if our computer is unable to make it its efficient or full usage of that component or the equipment. So for this reason, it is important for us to install or use a good operating system. What are the services that an operating system provides? Operating system provides services to ensure smooth operation of a computer. Key services include program execution, IO operations, file management, and communication with error detection. We look into each of them. Program execution. Loading programs into the memory and executing them is a very important task. When we run a program, it should be loaded and that should be executed in order to get an output. For this reason, we use a operating system. IO operations is used when managing input and output operations. File system manipulation, handling file operations such as creation, deletion, reading and writing files, reading a file that we are trying to manipulate. We can use the operating system to coordinate between the input and output devices, and also for making changes in existing files or create new ones or delete the existing ones. Communication. It facilitating communication between the processes. Process is a task that is that is occurring in it is in practice, and this one is used to communicate between both or two different processes. We can use the operating system. Error detection, we can detect and handle errors both in hardware and software. We can notice sometimes when we are trying to open too many tabs in our mid-end computer systems or something, it will show us that the hardware does not support our activity. All such errors and warnings are given by the computer and by the operating system, and these things are also managed by the OS. These services enhance the efficiency and usability of a computer system. That it makes the computer system more easily understandable, and even people who don't know much about a computer can also use the system using these operations. System calls. What is a system call? System calls provide the interface between a process and operating system. They allow user level process to request services from the OS. When the user prompts a issue to the OS, it has to have somebody who is conveying this message from the user to the OS. For this reason, or from the OS to this different resources that are available. For this purpose, we use system calls. What are the key points under this topic? Definition. System calls are programming interface to the services provided by the OS. Its role is to facilitate the process management, file management, device management, and information maintenance. For managing the different files we have, for keeping track of all the processes that are under execution, for the management of efficient use of devices that are connected to our computer, and for the maintenance of all the important information that we have in our system. This is the main role of system calls. Examples are open, read, write, close, fork, exit, and wait to kill are the few function examples of this system. These system calls. We can provoke, invoke, and do other different operations with it. System calls are essential for functioning of the OS as they allow execution of critical operations. The most critical, all the critical operations, even the basic ones to the most complex ones, are always including a system call. We have a small chart on how all these systems work. So we can use the kernel mode and user mode. About these things we will talk in our upcoming slides. User and kernel mode. Now, modern operating systems support dual mode operation to protect the system and its resources. User mode is a mode where the user application runs. Applications have limited access to system resources. If there is a program or a task that I am running as a user on my computer system, that comes under the category of a user mode. What is kernel mode? Kernel mode is the mode which the OS code runs. The OS has restricted access to system resources. When a user is using the computer, the resources that are allocated or utilized are also not all the resources can't be used. We have limited access. But in case of kernel mode, where the code is running, the OS is running its own code for maintenance and functionality of the computer, like the basic computer functionalities, this has restricted access to the system resources. The transition between user and kernel mode is essential for executing privileged instructions safely and securely. For a computer to be able to switch between these two easily is what makes the computer fast, safe, and secure. Process management. Process management is a process is a program in execution. As we discussed earlier, if there is a program that is being executed when we are discussing about it, that is called a process. Process management is a fundamental function of the OS to ensure efficient execution of a process. For making the OS function properly, we use the process management, where we have different programs that are being run, which is the responsibility of the OS. But how is it managing everything is what we study under this category. Process life cycle. A new process is created, it is ready and it is running and it is waiting in case there is any wait function evolved in this program, and then it is terminated. That is a life cycle of a process. Process control block or PCB contains process related information, the ID or the state of the computer, which registers are being used, and how much memory it is allocated. And scheduling determines which process runs when. There is a certain schedule that the OS prepares for when a process should be created, destroyed, and when it should work properly. Efficient process management is crucial for multitasking and resource allocation. We cannot use three different systems just because we are using three different tabs. For such things, we use one tab that is able to multitask between 3 to 4 different tabs that will support the user's operations. For things like this, it is very essential to have proper process management in our OS. We have a trigger message in the picture that will go into the proper process manager task, and it will be allocated which task is going to be performed when and at what time. And then these processes are communicating with the process manager, and then the output is generated and it is shown to the user. Memory management and storage management. Memory management is responsible for managing the computer's primary memory. It keeps track of each byte of the computer's memory and allocates and deallocates memory when needed. Paging segmentation are the few topics that come under this topic. So, memory management ensures efficient use of memory resources and supports processes efficiently. And when we have to run a process, it is very necessary for the process to accommodate proper amount of memory which it requires, and allocating that memory at the right time and freeing the memory when the processes are done is a very important task that the OS takes care, which will help us to manage the next programs to load it in the same places, which information is necessary, not necessary. These decisions are made by the OS. Storage management involves managing data resources such as hard drives and SSDs, and the data structures used to organize this data. And file system and file management are the topics that come under storage management. How is the file stores? How is it organized, and what are the common files that it includes, what are the operations, reading, writing, and all these different operations that can be performed on a file. These topics come under the process of storage management. Effective storage management is essential for data integrity, accessibility, and performance. For the system to perform properly, be integrate, and to maintain proper accessibility, that is, when we need the information, we have it ready. For such cases, we require storage management and memory management. IO system management, we have different input outputs that are connected to our system, and they have to be managed properly during the execution of a process. It ensures efficient communication between the CPU and the IO devices. When the CPU intimates that it requires certain output or input devices for its utilization, the The allocating of these devices and what they have to do is done by the OS. Buffering, caching, and spooling are a few topics that come under this category. Security and protection. Security protection mechanisms are crucial to protect the system from threats and unauthorized access. Authentication, encryption, access control are the few topics. We have to verify the identity of the user. We have fingerprints, we have locks, and we have passwords that we use before the OS loads into the computer, because it contains the very important information that we share with our systems, and keeping this information safe is a primary goal of the OS. Encryption of data will also keep it more safe, and even if there is a minor inconvenience, the information is not lost because it is saved by the encryption. Access control is restricting the resources, as we spoke earlier in the user mode case. It is important for us to know when we are utilizing these resources. User interface is the last one. We have command line interface and graphical user interface. Command line is the CLI, or we also call it command line interface, because these users interact using a command where the direct instructions is typed into the computer, and it is very powerful, but you need lot of technical knowledge or coding skills to communicate with the computer in a CLI format. But in case of a GUI, that is a graphical user interface, we have very simple graphical elements like windows, icons, buttons, which are very user friendly and intrusive. So these things make it easier for a person to use a computer even though they don't have too much knowledge about it. The conclusion is that operating systems are essential for managing computer resources and providing these user application. Key functions include process management, memory management, storage management, and IO system operations. Security and user interfaces are crucial aspects of modern operating systems. Understanding the structure of a vital IT professionals effectively manages and utilizes the computer system is a very important point that we cannot miss out in this topic. Last but not least, I thank you all for watching this video. Thank you.